Hi, everybody. How are you doing? Okay, let's check out your lab for this week. We will be doing lab 5 today. We'll start in 1 minute, okay? Let me share screen. You can go ahead and open your editor and your simulator for LC-3. Do you have any question before we start? I hope you did your assignment okay. I posted the video that I had done in the prior year. And if you have any questions, we can address that. Okay, so 6 o'clock, we're gonna go ahead and get started, and hopefully more people will join us, as I know that there are exams and things are going on this week in your other classes. So this week we are gonna do lab 5, and I posted also the code. So if you go to your Canvas course room, I also recently shared some announcements for other things. So if you're interested, you can check that out. Okay, so we are gonna do days of the week by entry, and the code you can find here, I commented, right? So you would understand, but we'll talk about it, okay? So this is like lab 3 in the lab manual for the university. And there is a second exercise. We are going to use the template from this program, and we're going to do a program that's going to output month instead of day of the week. So in this lab, we are going to write a program in LC-3, and we are going to prompt the user to enter the value between 0 through 6. And as they enter each of the input, we are going to display the day of the week, like Sunday through Saturday, on the console. So if the user enters 0, it's going to show Sunday, and so on. We need to first prompt the user the string, please enter a number, and we also want to put 0 through 6 for the day of the week. So you can extend this a little bit to make it more valid. Then to really explain this, for the string, as you know that we're going to use the LEA to load. And as the user input the integer 0 through 6, we're going to convert it. Now, to really understand the ASCII, you can open up your ASCII table. And so we are going to work with decimal in the conversion this week. So when you're looking at, so in the prior week, we talked about how when we have the number 0, your hex value is here, okay, 30. This week, we are going to use decimals. So your decimal value is going to be 48. Okay, and that's when we are doing the ASCII conversion. We have to add and subtract 48. Instead of the hex, we're going to use the hash and the decimal value. So at the beginning, it talks about how a string needs to be null terminated. So your string is going to load to the register, and that's how we're going to output it. Now, when you're using the day, one character of the is going to be in each of the memory locations. So for each of the word, which is 16-bit, it's going to present one of the character when it outputs it. So in the case if we're looking at Saturday, right, it's going to be S for one location, A for the next location, T for the following location, and so on. And each of the location is a word length. So we are going to use the least significant bits to hold the ASCII value for the character. So when the user enters 0, right, we have to convert that into your machine number. And then we are going to make sure that it's going to display Sunday. So here it talks about your strings, and we've worked with string for the last couple of weeks. And here it shows you Sunday. So when you are looking at the word Sunday or the string Sunday, you have 1, 2, 3, 4, 5, 6. 6 character with the null termination, that's going to give you 7 characters. So to display Sunday, the computer needs to allocate this much space, starting with the S in one address and all the way to the Y and the null termination in the subsequent addresses. Now, the important thing, and as you watch the lecture video, I have warned all the students that when you do this, make sure that your quotation and your characters are properly aligned. They are straight, okay? Because if they're off by one space, you're going to cut off one of the character in the longer days, like Wednesday. So when we're outputting on display, first we are going to display the string by using LEA, so load effective address. We're going to use the puts to be able to do that. And then we're going to reuse the register 0 for the input. Okay. So as we are moving things out of register 0, you're going to see that we have to free that up for input and output. So we don't really do a lot of the calculation at register 0. We're going to move it to other register instead by copying. Now, for the input value, we're going to use the getC. So we are going to record one character. And so that means that it's going to trap vector 20. So it's going to read the single character that the user input from the keyboard, put it into the register 0, and then we're going to take that value and we're going to ASCII convert it. Okay. Now, it tells you here that the 8th most significant bits of the register 0 are cleared because we're not going to store it there. Once it comes in, we're going to take that value, we're going to ASCII convert it to your decimal number, which the computer sees in binary eventually, right? And then we are going to put it onto another register. So as you see this, when we do a getC, we bring that into register 0. We're going to take that value from register 0, and we're going to copy it to another register like register 3. And then from there, we are going to convert it to a value, not a character, right? We receive the character in human number. We're going to make it into the computer number now by subtracting 48. So again, if you miss it, why am I subtracting 48? Because if you're using decimal value, not hexadecimal value, if you're looking at the character 0 on the ASCII table, your decimal value is 48. In the past, we've used hexadecimal, so we subtract 30. Today, we're going to use decimal, so we're going to subtract 48. Now, 48 is larger than when you convert it into binary, it's going to be more than 5 bits. And in the last 2 weeks, we talked about immediate value, and also in this week, when you initialize immediate value for the register, it can only hold the immediate value in 5 bits. So if you convert 48 as decimal into binary, it is more than 5 bits. So therefore, we have to add it in multiple times, okay? So that means that when you add the -16 decimal here, simply is subtracting 16. So when you add it to register 3, that's 1 time. And then you add it again in the second line, that gives you 32. And then you add it the third time, that gives you -48. So when the input is entered, it is in character. We need to offset it by -48 decimal to make it into what the computer sees as a value that's equivalent to 0. And then from there, we are going to change it into what we would output as a week of the day. So therefore, we need 3 lines or 3 instructions to be able to convert from your character to the computer number. And here it mentioned why, right? Because of the 5 bits for the immediate value, 48 will not fit, it overflows, so we have to chunk it into 3 times. Any question with that? Okay. So after we ASCII convert, when you declare your strings on the in the data section on the bottom, you would have these days. And so we would start with Sunday and end it with Saturday. And if you look at this section, this image, you would see how the quotation mark is lined up straight. So you want us to make sure that every of the strings that you declare have to start with the quotation mark, and it needs to align with the previous line. And then on the days that have less character, like Sunday and Monday, compared to Wednesday, Thursday, and Saturday, make sure that we have the proper 10 space, okay? So you gotta make sure that it goes all the way past equivalent to the Wednesday space, and then make sure that the quotation marks line up accordingly. Because if you put the quotation mark right after each of the Y for each of the string, you're going to end up cutting off some of the area. So make sure that we line up the quotation mark and make sure that we have proper spacing to the number of characters that Wednesday would be, even if there are no more characters after the shorter days, like Sunday, Monday, and Tuesday. So add the additional space after those, okay, and then enclose it with the quotation mark. So the length for Wednesday is 9 characters. So just count your space and make sure that they're straight. Okay, because if you don't, if you have excess, it's gonna lean into the next one and so on. So the white space here, it's actually taking up location, but we want to make sure that we include Wednesday, which is the longest for the number of characters. Okay, so Wednesday actually have 10 address spaces because there are 9 characters in the string. So and it's also null terminated, so that means that it's going to take up 10 addresses to make the word Wednesday. Okay, any question? So that means that when we're declaring each of the strings, we are taking up 10 spaces, okay? Regardless of whether it has less or equivalent characters. So on the Sunday, we're going to take up 10 space, and Monday take up 10 space, and so on. So now in the next section on page 3 of the lab instruction, It tells you here that if the numerical code of the day is I, the address corresponding to the day is found in the formula. So what happens is you understand that when we work with the string object in C or in C++, you are dealing with an array of characters. And so we would enumerate through each of the character to really access it and be able to display it. In that same concept, what we will do is we will place each of the character into each of the address space on memory. And we are going to go through each of the space sequentially to be able to access each of the letter or the character. So what you will have is you need to have the addresses set up. And so for your days, you need to increment it and you need to multiply it by 10 because there are 10 characters. Now, on the snapshot here, you see that we use the days label. And since LC3 doesn't provide multiplication operation, we are going to use the add method, right? We are going to add it to be able to increment it, okay? To be able to access the I, which is the index in the memory array. So here it gives you like a summary of how that should look. We load the string, right? We would load it to the label, which is days. And so it would start with Sunday here. And then we would do the condition code. So we would copy the R3 and we would create a loop. As you know that when we're accessing array in C or C++ or Java, we would use the loop to be able to access the index. And in this case, we are going to go through and we are going to check the branches to be able to go from one day to the next day to the next day and so on. So how does it know whether it's Sunday or Tuesday? Well, we would use the branch to do that. And we simply use comparison to check the value for what the user inputs. So if I have it 0, right, we can check for 0 to be able to display Sunday. But if I input a 3, it needs to display another day, and we would use a comparison to check that. Then once it goes through the looping process, and as we loop, we're going to count down, right? Like think about a for loop. As you loop through, in C++, we increment up until we reach a certain number. Well, in LC3, you would start with the maximum value and you're going to increment down. So you're going to have a decrement. So as you loop, you're going to count down one less, one less, one less, until you get to the end, which is 0. Then you are going to send it to either back. So in this case, we're doing a while loop. So when it gets there, it's going to come back at the beginning and it's going to keep going. So it's infinite. Now, in the case, if I want to exit the loop, I have to branch it to the 0. And then once it hits the 0, I can send it to a label, or I can have it go to the next line. Okay. So here we are going to do an infinite loop where it's always going to prompt the user to enter a number, and it's going to check that number for the day of the week. Any question? Okay, so let's look at our program. I screenshot it. I didn't comment everything on here oh yeah, I did. Okay. So at the top, we can put down the comment. This is lab 5 exercise 1. Our input is 0 through 6. And our output is going to be days. We don't have any side effects. And from here on out, you can use tab to make your label more clear. Okay. because down the line when you do your course project, it's going to be a lot longer and it is easier to see if you align things, and that way you can catch your error in case, if you need to troubleshoot. So at the top, we're going to start with the origination address. So .org hex 3000, that's where our program going to begin. And I have a label called restart. You can use any kind of name you want there. So the reason why I have it as restart is because I'm using a while loop and it's always going to prompt the user to enter a value. So here I have a restart label. And with that, I'm going to do an LEA, load effective address, to register 0 for the prompt. And I use a prompt as your label for your string to display. And I comment that this is to prompt on console, enter number 0 through 6. And you can add more to it, like for the day of the week, but simple instructions, fine. Then after the prompt, we are going to display it, right? So after we load here, we're going to do a puts. So that way it's going to show our string on the console. The next process will be to obtain the value. So here we're going to do a get C, and it's going to read the character input and know that it is a character, not an integer. So we need to take that character and convert it to an integer, which is why we are going to copy it and offset it by 48 decimal. So in the next line after get C, I'm going to copy what was input as a character from register 0 and copy it to register 3. So register 3 now holds the input value or input character. And then the next 3 lines are going to be that we are going to subtract 48. Okay. Because we're using a decimal, it has to be 48, 40. Okay. Now, not that we only have to convert it, we are going to offset it by -6 because we want to do input validation. We want to control what the user input between 0 and 6, okay? Because if you don't, it's gonna have issues, and if they don't put it in that scope, where's your program gonna branch? We want to control it so we can set the proper condition. And all programs should have input validation if you are recording input. So I will require input validation for your project, so make sure that we understand how to control what the user enter. So here we need to add -6 to register 3, which is a character that we converted. So now it is a value, and we need to offset it by 6. So if it is larger than 6, like if the user input 8 or 9, right, it would send an error or it would exit. Okay. So here we are going to put it into register 4 after we subtract 6 from register 3. And we are going to branch positive to error, which is a label. So if they enter anything that's larger than 6, it's going to go to the error section. Okay, so that is going to handle the input validation, those 2 lines. And then we're going to later declare what error would be. Now, in the next section, we are going to output the days. So you are going to have to load effective address to register 0 again. That's why we have to copy the input. And we're gonna load the days label like the example shown in our document. Then after that, we're gonna initialize register 3 at 0. So we're gonna clear clear register 3 using the hex 0 here. Why are we doing that? We're doing that to start branching. So it's gonna check the value in register 3 for 0. Okay? Because the first day of the week is Sunday, and that starts at 0. So here, if we initialize it at 0, we can start branching at 0. And I put the comment so it makes sense for you. Then after that, we're going to begin the loop. So our loop label is going to start with the branch 0. And if it checks register 3, and if it is 0, it's going to go to display. Now, what if it's not 0, right? It has to be 0 because we initialize it at 0. But in the case in other program where that register is not 0 and we force it to check for 0, if it's not true there, it's going to go to the next line. So here it's going to check for 0, and then it's going to send it to display label. Then after that line, we are going to add 10 to register 0. Why is it 10? Decimal 10 here represents the number of characters in the day, including no termination. So the day that has the longest number of characters, or the most number of characters, is Wednesday, and it's 10 characters with no. Okay. So basically we set up that space, right, for 10 characters. So here we're going to add 10 to register 0. And we need to count down. So we are going to subtract 1. We're going to offset register 3 by 1. So it's going to go from one location to the next, right? It's going to be 1, 1, 1. And so that way it needs to update the increment for the loop. And then once we get through the count, then we are going to branch back to loop again. Because it's infinite, we are going to do an unconditional branch back to the label. So since we send the branch to 0 to display, we now need to define what display is. So for display, we simply are going to output on console. So we're going to do a puts, show on console. And then we are going to load, right, for LF to R0. So we're going to load another label to R0. And LF is going to hold days as strings. Okay. Then we're going to do a put, show on screen again. And then we're going to branch to the beginning, which is going to prompt the user again. So once it shows all the characters for the day, it's going to come back to the beginning and it's going to start all over again. It's infinite. Okay. So after that, we have to declare what error section would be. And this was for input validation. So in the error, we're going to load register 0 with ERMS. And the label for ERMS is just going to be, here, let me show you. It's just going to show that they enter, it's an invalid input. Then we're going to display that on console. Then we're going to end execution. So now the data section. We got the prompt, which is enter value 0 through 6. Then we have to declare all your days. And notice that I have my quotation marks line up exactly 10 spots later for the enclosed. And then making sure that your character are going accordingly. Because if you don't, you are going to cut off some of the days and it won't display. Sometimes it display blank, sometimes it display 2 characters. So you got to make sure that, you know, this is properly lined up. So we have, once we have the days defined in strings, we are going to declare our strings for invalid input. And for LF, we are going to fill it at hex 000A. Why am I using A? It's because it's hex equivalent for 10 decimal. Right? We call here. So we're going to fill it with hex A. And we're going to end the program. So in a program like this, you really have to think about the physical space that you are using and how you can take that string and break it into word length locations. Okay, so if your string is longer than 10, I would need to fill larger values here, right? And then I need to set up where it's going to loop through and it's able to access all the characters in all the locations. LC3 or assembly is really how you think about memory spacing and you using that with the instructions. Okay, so as you visualize that, you're like, oh, I'm going to put each of the letters in each of the index in that memory array. I simply loop through and access it. And then I will come back to it right after it display it. And then we keep doing that. Any question as far as exercise 1? Okay, so I screenshot one and I put it on the lab page so you can use it. And this program has been refined since I started teaching LC3 because in the past, you know, even though, you know, it was good, we added some elements for other things like input validations and things like that to make it better. Okay, so let me come back to here and let me get my LC3 simulator up. Okay. All right, so now we are going to go ahead and after you finish writing your program, don't forget to save and assemble. Okay, so we can go ahead and assemble this. Make sure we don't have any errors. Then we're going to load it. And then we're going to run it. And so as you can see, the instructions here, that is looping, right? So here it tells me to enter numbers 0 through 6, so I can test it with the 5, and it tells me it's a Friday, and it keeps prompting again. If I test it with the 3, it should show Wednesday. If I test it with the 1, Monday. What if I test it with the 7? I got an invalid input and it exit. See that? So our input validation works. to a certain extent, right? An ideal input validation would be that it's not exiting. It will come back to the beginning and tell us to enter the right number. But you get the idea. Any question? Okay, so let me reinitialize this. Okay, so as you look at your program, not only to run your program, but to really correlate on what the lecture was discussing, right? Like how we were looking at traps. So here you see that when you put, that will be trap vector 22. When you do a get C, trap vector 20. And then subsequently starting with the address 3000 all the way through, because your program is fairly short, right? You would see that these are the allocation for your instructions. And then when you do a put inside that label or at that label, you also see the trap vector there. Okay. At the end, we halt, we would have a trap vector 25. So as you run this, you would see that it is infinite, and we can always stop it by clicking the stop. And if I enter a 9, it exits my program, or my program exit. Any question? Okay. So, any question? No question. So here I put a note that for your problem statement, right, you need to really think about how you would approach your program from implementing or in the process of implementing algorithm. And here our algorithm consists of sequential, conditional, and iterative procedures. Okay, where it needs to branch based on a certain condition. It also needs to loop, so that's iterative, and it needs to go from top to the bottom where it would be sequential. Okay, so after we run the program, we can test it with the values and then give me a screenshot. Now, if you come across challenges, right, or not, you can put your comment there. Describe how you would debug the program in the case you run into problems. I've taught this for a few years now, and every year there's always some challenges in declaring the strings, or if you have syntax error, okay? So make sure that when we look at the program, when we write the program, we check how we type and how we align the strings. So make sure we include the answer for question C and D for 1. And you can type it directly into the document and save it. If you don't have Microsoft Office, you should see the first module to be able to download it for your computer. Question. So this is the first class that I will go over exercise 2. As you watched my lecture video, you probably heard that I gave this as an assignment and I have the student figure it out, right? And then I give them extra credit. And every semester, I always get impressed on how many people come up with different solutions. Some were better than others. right? And when I looked at it, so some students, they would use, right, addition approach where they would add multiple input. So as you look at exercise 1, we're only recording one input, one number, okay? But if you're looking at the criteria for exercise 2, the one value only work up to number 9, okay? But how do I record 10 or 11? Or in the case where other program that I need to record larger values, okay? So you really have to think about how you're going to move each of the input, right, quickly, right, or immediately after it was input to free up that register for the next input. If you're using get C, okay? Now, I've seen lots of solutions that were turned in and I was impressed, okay? So today I'm going to show you one of the best solutions that were turned in. And, you know, and I went through a nice somewhat debug it. So you will see, and this was a student that is now at UCLA. So I want to share that with you so you can, and go over it with you so you can understand how to do it. Because in your project, you're not only going to have 2 input, you're going to have many inputs and you have to know how to do it. Okay. So a way that we can record many inputs is we can do multiple ins or we can do multiple get C. Okay, it all depends on what you're trying to achieve. So if we're using number 1 as a template for number 2, we simply can modify a few things on it and extend it to fit the criteria for exercise 2. So let's look at that. In exercise 2, it asks you to write a program that's going to prompt the user to enter a value between 0 through 11. And similar to exercise 1, the 0 is going to represent the first month of this year, which is January. And the 11 is going to represent the last month in the year, which is December. Okay. Now also keep in mind that the number of characters that you're using in your months are essential, just like how we treat the characters for our days. Okay, so make sure that we count up the number of characters for the longest string that we would have. Okay, so this was the criteria. We displaying month of the year based on the value that was input. Any question with number 2 before we start? No question, huh? Okay, so let me screenshot this real quick for you. Oh, it's really long. Hold on one second. Give me 1 minute, okay? Because sometimes when you're following along, it can be challenging line by line. So let me get this onto a document for you. And if you didn't get to do your assignment this week yet, make sure that you look at the video. And if you have any questions, please let me know. Most of the concept is just review from what we talked about before. And I don't want to give you my ASM file because I want you to be able to type it out so that way you can understand as you go. I'm going to need, hold on one second. Thanks. So this next program is going to be a little longer than usual, okay? Because there are input validation. Let me see where I'm at here. The puts in error. Okay, it's just the last part now. Okay, let me upload it for you real quick. So it's going to be right below your file, okay? We should have enough time to look it over. Okay, it should be there now. Let me reshare on my screen. So I screenshot it and I put it in this document right here. Okay, you can download it and look at it, or let me make it embedded. And I need to make it more accessible. Okay, so just, I'm gonna let you know that it is a little longer and I tried to snip it as fast as I could. So it might look a little misaligned there, but. Okay, so I'm gonna open it up in the editor, and as you type, you can also follow along. So in this program, we are going to do month of the year. We are going to acquire the input between 0 through 11 from the user. We're going to output month of the year. Okay. For our output, we're going to ASCII convert 0 through 9. And then similar to what we've done with the days of the week. And then we are going to have the 0 as January and 11 as December. Okay. So as we are doing multiple input, it gets a little more lengthy because you just repeat the process. It's simple. Any question? Okay, let's start. Like any program, we're going to start with origination address at hex 3000. I have a label here called start. And similar to the last program, we're going to prompt at the beginning. So we're going to LEA our 0. So we're going to load prompt to register 0. Then we are going to display the prompt. Then the next part, we are going to obtain the input and validate. Okay. So we're going to have a get C for the first input, get character from the user. We're going to copy the input and put it onto register 0. So because they enter the value here in register 0, we're going to copy it to register 4. Next, we are going to clear register 5. And we're going to use register 5 to ASCII convert. Okay. So why am I doing 57 here to load? Anybody know? So we are going to do the 2 complement, or you can use the negative because LC-3 allows that. Okay. So in the, if you look at your ASCII table, right? We talked about having the 48 at the 0. Okay. But not only that we have to offset it at 48, remember that we're not going from 0 through 9. Okay. We're going beyond that. Here we're going to do 0 through 11. So if you take 11 plus 48, you would have 57. Okay, why am I adding 11 to 48? Because we asked the user to input 0 through 11. So you have to take the 11, considering the 11, and you need to offset it. And since 0 is already 48 below, you have to add the 11 to make sure that it's also going to handle any number between 0 through 11. Therefore, we're loading negative 57 there. And this is one approach. You will find other ways to do this, right? But, you know, I thought this is pretty clever. So this is what I'm going to use to show you. So here we're going to add decimal 15 to register 5 since we clear it. Again, we're going to add 15. That makes us 30. So at this point, right, we offset it by 30. And then here we would then offset by 45. And then here we would offset by 57. And since this is positive here, we need to 2 complement it. So this is going to give you the 2's complement. And it's also noted up here. So now we haven't converted. This is only in register 5, right? Now we're going to take that and we're going to add it with what the user input because we copy it to register 4. So you are going to take the input and add it with the 2's complement of the offset and put it back into register 5. So your register 5 is going to be input minus R5. And now we're going to do input validation. So we are going to branch. If it's positive, we are going to send it to error. So the input is going to be ASCII value that would be higher than the character 9. And then we're going to clear R5. Why am I clearing R5? Because I got to get the second number. Okay. Now, on the second number, we are going to do the same thing, except for that we are only going to do 48. Okay. Because if you think about how the values is the first and the second digit, there is a first digit that can go from 0 through whatever, right? And then the second digit that needs to extend that to 11. So here, what we're going to do is we're going to load 48 offset to register 5, and we're going to ASCII convert it, okay, for the next digit. There are 2 digits in the input. So this is going to handle the second piece, the second input. And then we repeat the same thing that we did here. We're going to take that input and we're going to ASCII convert it by adding here. And for the error, instead of checking the positive, we're going to do the negative. So here you're going to branch negative. And if the input is lower than 0, then we are going to send it to error. Any questions so far? All right. So for the next part, I'm going to copy, right, register 5 to register 1. And this is going to represent the numeric value of ASCII for the character that's entered or that's input. So we put it on register 1. Then we are going to load the label called num to register 0. Now, from there, we are going to copy register 5 to register 3 because we're going to use that to convert it back and display. Why am I not using register 5? Because I'm still reusing register 5 for other things. I don't want to change the value in that. So I wanted to put it onto another register and manipulate in that new register instead of register 5. Okay. So from there, we are going to initialize register 3 to the 0 so we can branch. If it is 0, then we're going to display, right? So go to the display. Then we are going to add 2 because we are using 2 digits. So we have to up it by 2, including null termination. okay? Because if you up it by 1, it's not going to fit. Then we're going to do the increment, or we're going to count for the loop. So we have to subtract 1 from register 3. And we're going to branch it to back to mirror 1. So that's going to check again. So, okay. So it's going to re-loop again. Then in the display, just like exercise 1, we're going to put. And now in the next section, that's going to be the next input validation. So for our input validation, we're going to obtain C or get C. So get the character, copy it to register 4, clear register 5. We're going to offset it by 57 again, just like the top. We're going to do the 2's complement. So you can recopy it. Just make sure that you look at the difference, because down here, we're going to have some mirror 2 that's going to be different. Then we are going to get the second digit, offset it by 48 for ASCII conversion. We're going to 2 complement it for the offset. Then we're going to now convert it with, when you combine the ASCII conversion and the input, and put it back into register 5. Then we're going to branch for negative like the top. And so if it's lower than 0, right, that's going to send it to check enter label. That's different. Then we're going to copy register 5 to register 2. Again, we're going to load num to register 0. So we can start doing display. And then copy register 5 to register 3. Clear register 3 for branching. And then similar to the other mirror, we're going to branch, but we're going to use a different label. And here we're going to branch for 0, and we're going to display 2, because you have to display a second value. Otherwise, you don't want to reuse the same display. It's just going to be 1 digit. So you have to show 2 digit. Then again, we're gonna do the increment of 2, because it's 2 characters plus null termination. We're gonna count down for the loop, come back to mirror 2 with the unconditional branch. Then in the display 2, we are gonna do the puts. And then we're gonna branch to loop 1. Okay. Now here, we are going to clear register 5. We're going to add hex A to register 5 for a new line. We're going to do the 2 complement, so we're going to subtract it so we can start sectioning that space for our characters. Then we're going to re-add. So this is why we didn't clear register 5 up here. We have to use register 3, is because we're reusing it in another label. So here we are going to take the input, add it with the offset, okay, to convert. Now we're going to branch for negative and positive to error. So unlike the first program, this program had better input validation. It checks for everything outside of that scope. So here, if you have character that's outside of 0 through 9, it's going to go to error. Then we're going to copy register 1 to register 2, because remember earlier we used register 1, and then we are going to clear register 1 to start branching. So now we got to check for the tens digit. Okay. Because if the user input, right, because we limit it to 0 through 11, we got to make sure that it's in that scope, right? Anything outside of 11 is not going to go. So if they put 1, 2, which is a 12, right? Not that we only check for the 10 digit, we also need to check for the single digit. So that means that we have to do the input validation for both of the digits. This is why it's so much longer. Okay, so here, this loop 1 section, we are going to check for the tens place. And because here we clear, it's going to go to register 1 to look for the branch 0. And if it is 0, it's going to go to prep M. If it's negative, it's going to go to error. And we're going to add hex A to register 2, because that way we would store the index of your character for the month. 10 characters. And then we are going to not R1. And then so R2 here. Wait, I think this is the wrong comment. Oh, yeah. Add hex R1, not R1, add R1 with 2. And then we're going to subtract 1. Okay, and loop it back to the top. So we're going to move it down 2, and then we're going to move it back up 1, and then we're going to come back to the loop 1 at the end. Because we have to move 2 digits, then we're going to go back, we're going to count back 1 for the loop, and then we're going to come back at the beginning. So you can use decimal or hex 1 here. We use hex, but you can also use decimal there. But this needs to be a hex. All right. For the prep M, this is where you would be able to get your characters in. So we are going to load R0LF. So that will be a new line. So for your line feed, we're going to do the puts, show on screen. We want to input validate, make sure that the input is less than 12. So this is why we're going to add hex B to register 0. For that, it needs to be 11, as it needs to be less than 12. Okay, so we're going to put hex B on register 0. Subtract hex B. So your register 0 is going to be -11. And then we are going to add that. It should be register 2. Sorry, sometimes things get a little hairy when we track register here. Okay. So after we have set up the input validation for 11, we're going to branch it. So now if it checks that condition for negative and 0. So to really branch, you subtract 11, right? If it's 11, you subtract 11. it can go for 0, right? If it's 9, subtract 11, you have a -2. So you are going to do a branch negative and 0. That's how we can check for 0 through 11. And then we're going to load error num to register 0 for displaying error, right? And then we're going to output that on console. Again, load LF to register 0, display a new line, come back to the beginning again because it's infinite loop. So we're going to come back to the start. For the good in, when we're using the label here, right, we're going to load a label months to register 0. This is now we're going to show the months. We're going to clear register 3. We're going to take register 3 and set it up to branch. So we're going to take register 2, copy register 2 to register 3, and then we can branch to display. Then we're going to add 10 for 10 characters for the month. Earlier, we have to add ASCII here because it needs to loop 10 times. Here, we're going to make the array, it's looped through the array now. So we're going to add 10 for 10 characters in the month, including null terminated. And then we're going to count down as we loop. And then we're going to come back to the loop 2 again because it's infinite. We are going to display in the display section. So we put a new line, put again. Okay. So, and then we're going to reloop the prompt. In the error, we simply display the error message. So we're going to need to load LF and then put, and then load, right, for another error for the put. And so you would see the data section. After that, halt execution. So the bottom, we're going to prompt enter the number, and we are going to also input or show what they entered. Number 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then for the months, make sure that we line up our quotations and our characters and make sure it's 10 space later. The longest month is going to be your September, which has the most characters. So it will be 9 characters plus 1. That will be a 10 total. That's why we're using 10. And then for our input validation check for your error str, that will be input is not an integer. It's going to exit. For your line feed, we would do the /n. You can include it, but it's going to screw up all the subsequent memory addresses. So we have to treat it as its own string. Okay. And then for the error num, it's going to show input index entered. Try again. Okay. So after you build this program, save it and then assemble it. Okay. Then in your simulator, let's initialize the machine. And then we're going to go ahead and click run. So here's my console. Let's try 11. I got December. Let's try 3. Oops, sorry. 3 alone is going to be that it's going to see it as not an integer. So you have to use a double number because we're using double digit. Okay. So input validation work at exit. And then you can test it again by reloading and so on. Okay. And can you improve this program? You sure can, right? There are some areas that we can probably clean up. But this program gives you better input validation and it handles 2 digits. So as you can see, when we go from 1 digit to another digit, we have to think about how that mathematically use in how we allocate the space, how we offset it with ASCII, how we check input validation, and everything else. So you not only checking the first input, you have to check the second input to be thorough, right?
So, Professor, in the string section where the single digits are, um, since we're telling the program we want it to rate a single digit, how come that's not happening when we execute?
Yeah, because so in the single digit, okay, this checks for 0 through 9 for the 10 digit. Okay. So when I input the 3, it shows the 3, but it won't interpret only 3. It has to be 0, 3. I think I'm understanding your questions correctly. Right?
Yeah, that was right. Yeah.
Yeah. So in this one, we have to be a little bit more clear on how we want the user to enter. So perhaps we want to say input to number 00 to 11, like this, right? So the 00 represents January. Because it won't pass what it accepts, because we set it up to input validate a double number, right? A double 2 inputs. So if we only enter 1, right, and press enter, it was looking for a second one. So it didn't check true for the branch condition. So it's going to send it to the error message. And that's how you're supposed to do the double input, right? To really check and make sure that you're recording that. But I think in the prompt, we could do better in how we display this, right? Enter 2 numbers, 00 through 11.
Well, couldn't that just be enough, just the prompt, and we take away the number section? Because it's already assumed that you need to enter the numbers, right?
Yeah, but I think the intention behind this, and this was Kevin's idea, that was one of my former students, is to show what the number that they have entered, because Getsy, it shows what you've entered, but I think he intended to show like this is the number. Yes, you can probably, yeah, you can probably reduce that and take away the num section. But if you look up, where was it? Yeah, so I think he branched on num a couple of times. So I did modify a couple of things on here when I looked at it, but yeah, right here is where it checks for the input, and then it would load the characters to the 0, and then so he's using some of this to be able, and then he ASCII converted again. So it becomes a little longer, perhaps, over engineered. But it's good. I think it's thorough. But yeah, you're right. You can probably do away with some part of it. Okay. But as you look, a lot of it is repetition for some of the stuff, because we're checking the same thing, but for the second digit, we just gotta validate it that it's gonna be between, this and this. another way that you can do this is you can record the input, ASCII convert it, copy it to another register, leave that register there, record the second input, ASCII convert it, and then, but again, I mentioned this to last year's students, and I'm going to talk to you again. So when you're looking at the number, the 10 to the human, you got to make sure that the computer understand what the 10. Okay, that's why we were looking at the, otherwise it just be characters. So you have to take that and make it into an integer. So this is why we have to offset it. So if you're dealing with 100, then you got to make sure that you let the computer understand that that's a value for the 100. So you have to offset it after you ASCII convert it. So either way, you would still have to ASCII convert it. So if I approach it, right, I would ASCII convert it at once. So I would have one section that would ASCII convert it, and I would just loop it, right? Like I would just reuse that label for both of the ASCII conversion. And then on the next line, I would do the offset. Because as you can see, the way that we handle this here, we have multiple sections of the same thing. Well, you can use a label, send it to that label, do the ASCII, like the ASCII label, and then do the ASCII conversion, and then do the offset following. So it's a little cleaner. You know, so however you look at it, what kind of process should go through, but definitely you have to ASCII convert and offset for each of the digits that was inputted, and then store it, right? You can also store it to a label and then go and retrieve it and then do it. So you can shorten this to maybe half of the size if you use your label and things accordingly, and addresses. Okay, so there are other approaches. I've seen other students that turn it in where they use the labels and be able to go to the label and send that back. Now, coming from this program, which is in week 5, so when I see the project at the end, so much cleaner, so much better for all the students. And I see that how they see the label and how they use the label and reuse the label. And that's the whole point, is if you set up a memory location for a certain purpose, you should think about how you can repurpose that section. And that's how we strive for efficiency, is to be able to reuse that if we can. And this is why when you do this in C++ and Java, is when you define a function, right? And if you can reuse that function, you just go and call that function again. So the same concept is that if you declare something, and if you have the same need for it, you should go back to it and reuse that label and redo that. So think about how you can streamline that and make it more efficient. So if I clean this up, I would clean up this section right here, right, for the ASCII conversion, and then for the offset section, and then possibly, because it's repeating, you see, and it makes it much longer. And then for the input validation, we can probably set up one section or a couple sections for the input, and then just send it back to the input through comparison. Okay. But this is the first class that I actually sit down and do this, because in the past I thought that maybe, you know, but if you want to write a better program, you can definitely do that and turn it in. I like to look at your screenshot and things like that when I go through and grade. And if it looks interesting, I'll take a look at it, and, you know, I'll rewrite it and see, you know, and then I'll share it with the next class. Questions? Yeah, so the size of your project, your course project, is going to look something like this. It's going to be a little longer than your normal program. Okay. I've had students turn in 1,001 line for assembly for their final project, and I've read through, I have to sit there and read through, I check every single line. So sometimes project for this class takes a long time to grade because it just, just a lot just to accomplish whatever simple task that we're doing. But it shows that you understand, right? And I will share with you your project in a few weeks, about week 9 or so you can start working on it in your group. Any question? Oh, even that we finished early. Okay, so when you build this program, check for the input, right? You can see if, let's see if you can input, a large value, a small value, see if input validation works, and also if it's displaying the right month. And if you line up your month accordingly, it should not cut off any letter or show blank, because if it's showing blank, that means that you just didn't type it out with the 10 space and the proper alignment.
Professor, one final question just for clarity. Can you explain the mirror section? I'm just curious, what does that do?
Yeah, so when you load the characters here, okay, you send it to num, and num we saw that it was 0 through 9. We want to copy and display for just, what was it? Yeah, so this is just gonna show you how your character, the first character, is the same as your second character, right? But in the first character, you notice that it's still doing the same thing. So for the mirror one, when we branch 0, we send it to display, right? We add the 2 because the characters of the numbers, including null terminated, there's 2 characters that we're working with, and we need to offset it by 1 to update your loop. And then we're going to branch it back to display again. So mirror is really to get that ready for the next input, for the output, okay, for both of the characters. Now, can you put that all in one section? You can. You don't have to make it a separate label, but the way that this is used here is that he branched it to the 0, and so it would be able to set up for 2 digits, to show 2 digits, because otherwise it's only going to be able to pull 1. So we want to make sure that it's going to put 1 next to the next digit. And so I think that if I redo this, I would take this and put it into, yeah, so you can definitely combine this with this. Okay. And for the second mirror, it's doing the same thing. So it's prepping the second value before the display. Okay. So here it's going to go loop, it's going to branch to display, which is just going to show, right? And then it got to have 2 because it's got to move from the first digit to the second digit for the 2 digits. Then that's including null terminated. And so that's just prepping for the display in the next section.
All right, thank you.
Yeah, it seems confusing, but yeah, you can think about how you can combine these 2 together without having to branch it. You can branch it directly to the display by putting the Z there, and then just before the put, you can do the add before it. So you can take those lines and put it here, and then do the put. right? Because these lines are not branching to anything. So if you clean this up, you can take this and put it before the put, because if you BRZ to the display two, it's going to send it to the display anyway. So that's another way that you can minimize some of the labels on this. I have other solutions that are pretty good too. And so if you're interested in that, I can probably share that with you on via GitHub. I did that in the past for the extra credit. And you will have other extra credit opportunity. So the person that wrote this, right, he was highly interested in learning assembly to write compilers. You know, that's really where his passion lies. Is, you know, he started learning to build compilers in other classes that he had taken. So he wanted to really pursue that. And so when I gave them this challenge, you know, I chose this because it's thorough, but there are other students that did just as well. And so, you know, kind of give you a little bit of, even though it's redundant, but you can understand the offset a little bit more on how we convert that. Okay, any other questions? Now, this exercise is not part of the lab manual. Okay, this is an added exercise that I wanted to use from exercise 1. I thought it will be fun to look at how we would treat double digits. So this was what I implemented. So when you look at the university lab manual, it only handles exercise 1. There is another exercise later on that we're going to come back to the days of the week, but we are going to apply multiplication. So we are going to use multiplication function or subroutine to be able to do some of this. And so you can see, instead of just adding and so on, right? Because you can see, oh, well, we can just make a function and then call it. And so that way it will just convert and use the function label to do that. Okay, so let me stop recording.